drive the SIM429-11 interface, we need a simple operating system such as OS X running a flight simulator like X-Plane. For our test case, we want to drive a real-world avionics instrument like an HSI that we pictured here. The V1 Avionics SIM429-11 interface will send standard ARINC 429 data from the interface to the HSI. It uses the transmit bus on the interface. ARINC 429 is a standard digital avionics format. We receive data from the simulator through a plugin called the TAP plugin. This plugin will be available for Microsoft Flight Simulator as well as Lockheed's Prepared and other flight simulators. There is also a device driver called the SIM429 device driver running on the computer running the flight simulator. The device driver sends configuration and data to the interface through standard Ethernet. So data flows from the simulator through the TAP plugin to the device driver to the interface and then on to the HSI. Here's our demonstration setup. To drive this setup, we use two V1 Avionics SIM429-11 interfaces, one driving a 12.5 kilobit bus and the other one a 100 kilobit bus. Each interface has an Ethernet connector, a USB connector providing power, and a multi-purpose connector. The multi-purpose connector supplies power, has an ARINC 429 transmit and receive bus. The two buses need to be split out into individual buses. There are 5 12.5 kilobit buses and one 100 kilobit bus. So let's go for a test flight. First we start the SIM429 device driver in foreground mode. When we do that, it resets the HSI. Then we'll start X-Plane. X-Plane will send data to the SIM429 device driver through the TAP plugin. We're just going to pick a generic aircraft here and put ourselves on the Seattle-Tacoma Airport on runway 16.
November 01 X-ray.
The HSI shows the corresponding data produced by the simulator in the real world. This data is now moved by the TAP plugin to the SIM429 device driver to the interfaces and sent on to the HSI on 12.5 and 100 kilobit. The first thing I want to show you is how to move the heading cursor on the HSI. So this heading indicator right there corresponds to the magenta heading indicator. The autopilot in the flight simulation software has the ability to change the heading cursor. So I can increase the heading, so turn it over to the right, and you will see that the HSI shows the real data. This is 12.5 kilobit data provided to the HSI. Let's roll it in the opposite direction and you see the same data. So this interface here provides the 12.5 kilobit data and sends it on to the HSI. Next, let's look at some VOR data. First we have to find out what the proper VOR here at the Seattle-Tacoma Airport is, and the frequency is 116.8. So let's make sure that frequency is dialed into our nav1 radio here, and we'll toggle the frequency, and immediately we'll get a proper indication pointing to the VOR. The HSI reflects the same data. When we rotate the OBS for the VOR, the HSI adjusts smoothly and evenly as we rotate through the individual data values. The to and from indication for the VOR also changes in synchronicity with the actual flight simulation software. This is ARINC 429 data sent on 12.5 kilobit. Let's go flying. For this test, we want to take off from the Seattle-Tacoma Airport runway 16 and then intercept a from radio of 180. Again, as we make these adjustments, data is immediately sent on to the interfaces. During this test, I also want you to pay attention to the ground speed. The ground speed on the HSI can be seen in the top right corner of the instrument. So let's put in some flaps here. We'll do flaps 10. We'll pre-program the autopilot So we will pre-program a airspeed of 200 knots. Let's go down here to 200. We'll adjust the heading bug to show the actual runway heading, in case we wanted to have the autopilot fly the runway heading. And we will set a vertical speed of 1,000 feet per minute. We'll keep the target altitude the same as it is set right now. So here are the two interfaces, top one 12 kilobit, bottom one 100 kilobit. We'll turn on the flight director and check our frequencies here, and everything is set. Again, here is the VOR, and we will look for corresponding data on the real HSI here. So you see the heading bug, the VOR OBS setting, and let's go ahead and go flying. Alright, so data is being sent on actively to the interface. The ground speed is building. So this is 100 kilobit data now for the ground speed. And as we go through 80, so we're active. And we will rotate at about 130, so V1, V2 rotate, and we're airborne now. And now the HSI will show us both 12 kilobit data for the VOR and 100 kilobit data for the magnetic heading as well as the ground speed. So this is now a mix of data sources. Okay, first thing we're going to do is we will adjust our heading bug to roll the aircraft to the right, so we can start intercepting this VOR heading over here. So here is what this looks like on the simulator, and you saw the corresponding data change over on the HSI. So we activate the autopilot to actually fly towards this heading. We set with the bug right there, and that's 12.5 kilobit data. So data flowing nicely into the interfaces right there. And you can see that we're starting to approach this radio coming off the VOR, and we just told the autopilot to intercept this particular radio and turn into this heading here and line us up with a heading of 180. This was a demonstration of mixed data, both 12.5 kilobit and 100 kilobit data on ARINC 429 coming out of two SIM429-11 interfaces provided by V1 Avionics.